Hi and welcome. Today we're going to have a look at how simple it is to start machining with Turbo HSR and HSM for 3D operations. As you can see, to start off with, I've come to Turbo 3D HSR. I've picked a stock and respecting the fixture. I can then go and select a tool, in this case a 20mm mill. I can then go and check the level of clearance, the constraint I want it to work with, which it picks automatically, as well as a step down, which I'll pick 3mm in this case. From here, I could change the top and the bottom if I need to, and then save and calculate. The stock will be calculated and the toolpath assigned to where material needs to be removed. And straight away you can see this is done. You can see at the top of the part, I haven't got a toolpath, so I've added 2mm to the top. You can see that calculates quickly. When we go to simulate this, we can see this material will be removed as we increase the speed of the simulator. As the simulation progresses, you can see the tool working around the job to make the 3D roughing that we require. And from there we might have some areas that might be too deep for us to come in with a finishing pass, and therefore we could use rest roughing. Turbo HSR is really easy to turn into rest roughing. Just by the drop down you can click THSR rest. From there all we need to do is change the tool, and in this case we'll use my 8mm ball nose mill. And then we can also pick the reference tool, which I'll just assign a diameter of 20mm, and it'll use the global offset for roughing. In here we could change the step down again to 1mm to get some better resolution if need be. If I go save and calculate, you can see this calculates for us really quickly, and we can then go and check the simulation of what we want to do. From here, as we'll see, as the stock builds up, it goes in and attacks the little corners that we might not have been able to get to with the 20mm mill. From here, we can go and say the roughing is complete, so we can move on to Turbo 3D HSM. I'll start off with a constant Z path, but this can be easily modified, and in this case I'll use combined with constant step over to make sure that all surfaces of the part get equally machined. For tooling, I've got a 10mm ball nose cutter, which I had in tool storage, and I've just added that to my magazine spindle. From here, we can go and check the levels for the plane height, as well as where we're going to machine with the constraint boundary, as well as what the step down and step over may be. In this case, I've set this to 0.5mm. The step down be for the constant Z, and the step over for the constant step over. And there's also the angle limit of 45 degrees. That tells the software where to go and add the constant Z values between 45 degrees and 90, and the constant step over between 0 and 45. As you can see, as the calculation completes, that gives us a toolpath that goes around all of the part, and it gives us a really nice finish. We can then go and simulate this and see how this looks on the model. It builds the stock model from what we had previously, and you can see the constant Z passes are done first. Now in the software we can choose to do them last if wished, but in this case I've chosen them first. We can also see the difference of where is 45 and 90 and where is 0 and 45. Obviously the constant Z only hitting the areas between 45 degrees and 90. From there we can see now the constant step over starts going through and cutting the material away where needed. It's a great toolpath for areas that are shallow, and you can see goes and cuts across them with relative ease by wrapping a contour operation up and down the slopes where needed. Finally, as this finishes, we'll further increase the clip speed just so we can see the finish of the toolpath, and you can see it goes round and clears up every part of this part really nicely. So I hope this has been a good first look and run through of Turbo HSR and HSM inside SolidCAM for you, and I hope you've enjoyed.